Okay, guys, it's about 11 o'clock on Saturday morning, 8:29. I am putting together this quick video on how to go over chapter 43. I'm going to share my screen with you right now. Okay, so here we go. Chapter 43 is the principles of braking. I would like you guys to get into the introduction. You can take the pretest if you'd like. It doesn't count towards your grade, but it's a good way to see how you are doing in your knowledge, and you might find some deficiencies there. When you click into the introduction, I'm already logged into CDX, but those of you that have already purchased CDX, this will come up and you will start working your way through the information. So here's the introduction. When I hit next down here, it's going to talk about the different types of braking systems. I expect that you're going to read through all of this. Let me move to some other tabs. Then there is a point one quiz you are going to take. Move to the next one. I'm hoping there's going to be some videos. Now, this is what I want you guys to pay attention to. There's the glossary. If there's a term that you don't know, you can click on this. It's all hyperlinked, and you can look at the vocabulary. So this is quite helpful. There's also these theory videos. I expect that you're going to look through all of these. I am not going to spend the time to look through those videos with you. So here's just an example. They are quick. They're 2 to 5 minutes long.
Several factors can influence vehicle braking, including road surface.
So I expect that you're going to look through all of these theory videos, look through the skill videos, look at the animations. These are all here to help you understand what we're looking at. And since we are not in the classroom, you need to take responsibility for your learning. You need to look through all of these things. Okay, once we start getting caught up, I will make sure that everybody is on track. And if you do not stay on track with the learning, you will not be allowed to come into the on-campus labs. Okay, but I will make that very clear when that is going to happen. Let me get back into our module. When you guys take a look at this after this recording, I am going to place the recording just above the chapter 43 pretest. And obviously you would have found it because you couldn't watch this video without finding it in the module. So anyways, I will also send you guys the link via email, but the link will also be here so you can watch it at your pleasure. Take a look at all of these different things. We have this, these AOCs are just labeling the diagram. This is a good way just of labeling what each piece is. This happens to be a air brake operated drum brake setup. Anyways, you're gonna play with all this stuff. Just good fun. All right, so as you make your way down, oops, wrong chapter. I would like you guys to take a look at all of these videos that I have here. These are all YouTube links, and I'm expecting that you guys are going to be watching these YouTube links. There's a lot of good information in here, and so I'm hoping that you will spend the time to watch these YouTube videos. Next week, when we're in the shop, we are going to begin master cylinders, which happens to be the next chapter. I know we're a little bit behind. All of this work right here will be due by Monday, and then I will have another video for chapter 44, which is hydraulics and power brake theory. So we will start looking at master cylinders and power brake boosters and how those operate, how to test them, how to R&R them. And so we'll be working on those inside the on-campus lab. All right, so let me get up into here. I am going to use a Toyota PowerPoint because I like to use just a little bit different information that you're already being subjected to. So I am going to work our way through a Toyota PowerPoint, just again, because it's this pretty much the same information, just put in a different way. So the fundamentals of brake systems, we're going to be taking a look at energy conversion, basically converting kinetic energy into heat energy. We are going to talk about force multiplication, basic brake systems, and brake system concerns. All right, so kinetic energy is the energy of mass in motion. When it's time to stop the vehicle, the brakes, which are connected to the vehicle, press against a rotating surface, which is either the brake rotor or a brake drum. And that is connected to the wheels, and the friction between those two surfaces, the brake pad or the shoe rubbing up against a disc brake or a disc or the drum, is going to convert the kinetic energy or that mass in motion into heat. And when you take a look at some of those videos I have down there, you're going to find, especially I think I have the Ferrari going around the racetrack, and you'll see how slowing down the vehicle makes the disc brake rotors glow red hot. So kinetic energy is going to increase in direct proportion to weight. If you double the vehicle's weight, its kinetic energy is going to double. So that is linear. It's a little bit different when we're talking about speed. So kinetic energy increases in proportion to speed squared. So it is exponential. If you double the vehicle speed, its kinetic energy that's built up in the car quadruples, and the brakes have to absorb 4 times as much heat to stop the vehicle when you double the speed. So speed has a much greater effect on the brakes than does the weight. The coefficient of friction, or COF, is a measurement of the friction between surfaces. The ideal COF, or coefficient of friction, for braking is about 0.33. At this level, the brakes can be applied smoothly and stop the vehicle. And so when the coefficient of friction is too low, the vehicle will stop too slowly. And when the coefficient of friction is too high, the brakes are going to lock up. And we don't want that to happen. So we want the brakes to be right on the cusp of being very effective, but not so effective where it's going to lock the wheels up, cause the vehicle to skid out of control. Okay, so the amount of friction between two surfaces and the material, and the amount of heat that's generated during braking is determined by 3 main factors. It's going to be the composition of the surfaces. So some of the materials are stickier than others. They're going to have a higher or a lower coefficient of friction, meaning that the choice of brake pad material, the choice of rotor or drum material, what it's made out of. This is why we always replace drums and rotors in pairs. We do not want there to be a difference in the coefficient of friction between left and right side of the vehicle. The condition of the surfaces will also have an effect. Maybe having rust or corrosion or scoring can have a significant effect on the coefficient of friction. For example, if you live near the ocean, on the first brake apply, there might be rust that has accumulated on the rotors, and that will affect the coefficient of friction. Or you park next to a lawn and the sprinklers went off and it got the rotors on the right side of the car all wet and rusted up the right side braking systems. That could make the car pull left on the first time you apply the brakes. The pressure that's applied between the two surfaces probably has will have the greatest effect. If you have a problem in a brake line, you have a problem with the hydraulics, and we're applying more brake pressure to one side versus the other, the side that's receiving the most brake pressure is going to make the car pull in that direction. So we have to watch out for that. All right, so here we are. We're getting into the hydraulic force multiplication. And this is going to be a result of what we do in the master cylinder and what we do down at the brake calipers and wheel cylinders in the drum brakes. So a hydraulic system is a closed system filled with liquid. Because liquids can't be compressed, when pressure is applied to the master cylinder piston, that same amount of pressure is instantly applied to the rest of the system. And by varying the size of these pistons at the wheels, we can increase or decrease or make the same amount of pressure applied out the other end. So if, for example, let's say if there was just one wheel cylinder at the other end of the hydraulic system and it had the same diameter as the master cylinder, the wheel cylinder would travel the same distance and exert the same amount of pressure. So if we have a 1 square inch piston here and we have a 1 square inch piston here and we move this 1 inch inward with 100 psi, we will get the same that comes out the other end. But brake systems need much more pressure, so we have to multiply that pressure at each wheel in order to stop the car. Drum brakes have a large cylinder volume or have a larger cylinder volume than the master cylinder, so when pressure is applied, the brake travels a shorter distance but applies a greater pressure. Disc brakes, on the other hand, are smaller and have less contact with the wheel than drums, so they require even more pressure. So, for example, in this picture, this would be more indicative of a brake wheel cylinder found in drum brakes. Calipers, they got to have a lot more surface area because the pad is smaller and there is no multiplication being generated by the shoes. We'll talk more about multiplication, mechanical multiplication from the drum brakes when we get there. We have a ways to go. Anyways, so since disc brakes have a smaller braking surface, they're going to require more pressure in order to stop the car. Hydraulic systems only work because liquids can't be compressed. If air is introduced in the system, guess what? The gas will compress under pressure and the system won't be able to apply full pressure to the wheels. That's bad. All right, so let's take a look at some of the different brake systems here. So brake systems are going to basic brake systems are going to be comprised of the following. We're going to have a reservoir up on top that's going to store all the fluid until it's needed. We have a master cylinder that is going to create the pressure that we need. The brake tubing is then going to route that brake fluid under pressure to the individual wheels. Disc brakes that apply pressure to a rotor to generate the friction needed to stop the vehicle. Almost all vehicles use disc brakes on the front. Some use four-wheel disc brakes, but there are many cars that are going to be using drum brakes, and these are typically vehicles that cost less to manufacture. So we're talking like a Toyota Corolla, Nissan Sentra, Nissan Versa, vehicles like that. Whereas when we get into larger, more expensive vehicles, they're for sure going to be four-wheel disc brakes. Let's see here. Other components are going to be including a vacuum brake booster. That's pictured right here. We use vacuum to multiply the force being created with us stepping on the brake pedal, or we could have a hydraulic brake booster. I mean, this thing looks crazy. We'll show you a couple of these. We have a couple vehicles with this type of brake booster in the yard. And we also have Jeff's pickup truck that has a hydraulic type booster in there. They feel completely different than a vacuum type. Vacuum type is the most common that you're going to see. We're also going to have a proportioning valve, and this is going to allow more brake pressure to act on the front disc brakes than in the rear, whether it be drum or disc. We want to limit the amount of brake pressure going to the rear because of weight transfer. When you step on the brakes, a majority of the weight of the car is going to dive down onto the front tires, loading them. And what that's going to do is unload or take weight off the rear. And we do not want the rear brakes to lock up because if they lock up, especially when you're in a turn, you are going to spin out of control. So we don't want that to happen. All right, so we can have some problems, and brake fade is a major problem. Now, the type of brake fade, there's a couple. There's mechanical, friction, and hydraulic. Mechanical brake fade tends to only affect drum brakes, because as this drum becomes heated, the metal expands and the drum actually grows. It gets bigger. And since we're using the inside diameter of our drum, the drum brake shoes will have to expand out further in order to keep contacting our expanding drum. And so that's one that is a type of fade that is pretty scary, because it will make the pedal sink to the floor when you're trying to stop the vehicle. Let's see here, friction material fade. If we were in the classroom, I would have different slides to show you, taking a look at different types of coefficient and what happens when it's cold, brake material when it's cold versus as it gets overheated. And essentially what happens is that when we overheat the brake friction material, the coefficient of friction falls off, and the car kind of feels like it's speeding up because it's not slowing down anymore. And unfortunately, once you get into material fade or this type of brake fade, it's going to be very difficult to stop the car. Now, hydraulic brake fade is when we get the hydraulics. This is the wheel cylinder. These don't tend to get that hot because the friction material is way out here, and it has a lot of material for the heat to make its way into this wheel cylinder. Now, on a brake caliper, the piston and the fluid are resting right up against the back of the friction material, and it tends to transfer a lot of heat into the brake fluid. And those of you that made it to school this last week, we actually tested the brake fluid by boiling it using a tester. And if we allow the brake fluid to get too much water in it, the boiling point of our brake fluid will get so low that we could actually boil the brake fluid in the lines, and that brake fluid will then gas. And the gas doesn't go back into the fluid when it cools down. The only way to get these gas bubbles out of the fluid is to bleed the brakes. We have to actually flush the fluid out. Okay, so here's a couple different brake fluids that you guys are going to see out there. DOT3, and DOT stands for Department of Transportation. So we have DOT3, DOT4, DOT5.1. These are all polyglycol. They're amber in color, and you can see our dry boiling points. You can see our wet. This is the minimum it can be. They're all compatible, but I will tell you, if the vehicle came with DOT3, you put DOT3 back in it. The viscosity of these fluids could be different, and that can affect the ABS braking. DOT5 is a silicone. It's purple. It's not very many vehicles or motorcycles use this. There are a few vehicles. I mean, there are a handful of motorcycles and cars that will use this, but it is not compatible with polyglycol, and it is not compatible in these brake systems. It will destroy it, so do not put that in there. Okay, so we are at the point where we are going to stop. Let me continue to get back into here. We will pick up in the next chapter on the master cylinder. The master cylinders, these guys are complicated somewhat. When you guys are going to take the ASE exam, you need to review master cylinders and valving. I will try and hit this the best I can and to provide you the most information I can online so that you can go back and review it. It's very important that you have a good understanding of master cylinders, proportioning valves, and all these different metering valves that you will see out there in industry. Really, because it will aid you in the diagnostics because you'll get some weird problems out there, but you will also be asked many different questions during the ASE break exam, and you need to have an understanding of how this stuff works in order to answer the questions. They're very difficult. All right, so let me stop sharing my screen. So I hope you guys have a great weekend. Again, I am going to add those due dates to the Canvas assignments. This chapter is very, very easy. Just please read. It's only like about 4 pages of information. Read through it. Look at all the videos. Make sure you look at all those theory videos that are very top of the CDX heading. Make sure you look at all that. Make sure you play with all the AOC, air brake, electric brake, forms of energy, all that good stuff. Please take a good look at all this stuff and have it done by Monday. So anyways, I hope you have a great weekend, and I will be talking to you, all of you soon. Take care.